You know when your Python classes just feel a little heavy? Like they're carrying around some extra weight you can't quite put your finger on. Well, today we're going to pull back the curtain on underscore slots, a seriously powerful feature that can make your code so much leaner and faster. If you want to supercharge your objects, you're about to learn one of Python's best kept secrets. But before we dive in, I've got a question for you. What's the hidden cost of every single object you create in Python? Now, it might seem like a tiny detail, but trust me, when you're creating thousands or even millions of objects, this hidden cost can be a real performance killer. And that question, well, it gets right to the heart of the problem with standard Python objects. See, they're designed to be incredibly flexible, which is great, but as we're about to find out, that flexibility comes at a price. So, what's the culprit here? Under the hood, every standard Python object is basically carrying around its own personal dictionary. It's called __dict__, and it's where all the object's attributes get stored. This means every time you do something simple like student.name, Python is actually doing a dictionary lookup in the background. So, what's the big deal? Well, having this dictionary for every single object creates a few headaches. First, dictionaries themselves take up a surprising amount of memory, which adds bloat to each object. Second, while dictionary lookups are pretty fast, they're just not as fast as directly grabbing a value from a fixed spot in memory. And when you do that millions of times, it really adds up. And finally, because it's a dictionary, you can add new attributes whenever you want. That sounds cool, but it can lead to some really messy, inconsistent objects and bugs that are a nightmare to track down. All right, so how do we get around this? What's the fix? Well, thankfully, Python has this really elegant built-in solution. _slots. At its core, _slots is basically a special instruction you give to a class. You're tapping Python on the shoulder and saying, hey, for any object of this class, just forget that _dict thing. Instead, just set aside a small, fixed chunk of memory for these specific attributes I'm about to list, and that's it. You're declaring exactly what your object is supposed to look like up front. So let's just put it side by side. Your standard object has that _dict_, which makes it heavy on memory, but super flexible. The _slots object, on the other hand, ditches the _dict_, uses way less memory, gives you faster attribute access, and has a fixed predictable structure. It's really a trade-off, right? You're swapping that add anything, anytime flexibility for a huge win in performance and efficiency. Okay, so this sounds pretty great, right? But how do you actually put it into your code? You're gonna love how simple this is. Seriously, it's just one extra line of code. Right inside your class definition, you just declare __slots __, and assign it a tuple containing the names of the attributes you want. That's it. You don't have to do anything else. Python takes over from there and handles all the memory optimization for you. And just like that, boom. The moment you add that one line, you unlock all those benefits. Your objects instantly get lighter, accessing their attributes gets a nice little speed boost, and your class design becomes way more solid because its structure is now locked in and enforced. Okay, but it's not all sunshine and rainbows. Like any really powerful tool, you've got to know the rules and the potential dangers. You can't just slap slots on everything, so let's talk about what you need to watch out for. So what happens if you try to break the rules? Let's say you told Python your student class only needs name and age in its slots. What happens if you then try to add a roll number later on? Well, Python will stop you in your tracks with an attribute error. The object literally has no place to put that new information. Now, I know what you might be thinking. An error? That sounds bad. But trust me, this error is actually your friend. Think of it like a guardrail for your code. It physically prevents you or someone else on your team from accidentally adding weird attributes, and it guarantees that every single object of your class has the exact same structure. That makes your code way more predictable and way less buggy. And what about inheritance? This is a super important rule to remember. If a child class also defines its own _slots, it doesn't just replace the parent slots, it adds to them. So if you have a person class with a slot for name, and then a student class inherits from person and adds its own slot for role, every student object will now have slots for both name and role. They combine. So let's be super clear. When should you absolutely not use _slots? Well, if your design requires you to add attributes to objects on the fly, _slots is a no-go.
If you're working with a library or some piece of code that expects to find and use that underscore dict, you're going to break things. And honestly, if you're in the very early stages of a project, just messing around and prototyping, the flexibility of a normal object is probably way more valuable than the micro-optimizations.
All right, so this all sounds cool in theory, but where does the rubber meet the road? Let's talk about where you'd actually see underscore slots out in the wild.
Think about any situation where you're creating just tons and tons of small, identical objects. In game development, you might be creating thousands of particle effects or bullets. In data science, you could be instantiating millions of objects to represent data points. In simulations or AI, maybe you have countless little agents running around. In these high-stakes cases, the memory savings and speed boost you get from underscore slots aren't just a nice-to-have. They are absolutely critical for performance. And hey, for all you modern Python developers out there, I've got a fantastic little tip for you. Data classes make this whole process even easier. You just add slots equals true to the data class decorator, and that's it. You get all the awesome benefits of underscore slots underscores combined with the super clean and convenient syntax of a data class. It is truly the best of both worlds.
So, let's wrap this all up. What are the big things you need to remember? First, slots locks down your object's attributes to a fixed list. Second, its main purpose in life is to save you a ton of memory and speed up your code. Third, remember this is an advanced tool for optimization. And finally, and this is the most important one, use it deliberately. Reach for this when you know performance is critical, not for every single class you write.
So I'm going to leave you with this challenge. Now that you have this new power in your Python toolkit, I want you to go look at your own code. Where is that one class, that one performance bottleneck that's just begging for you to apply underscore slots? Go find it. Thanks for joining me on this deep dive.